Good morning, friends. I welcome you all here in my course, Engineering Thermodynamics. Today, I am solving some exercises related to the pure substances and their properties, part 2. In part 1, I have solved 3 problems and hope those problems you might have observed. Very practical issues related to the pure substances. In this, I am going to solve only 2 problems, and these problems surely will be very interesting and very useful. So, please be tuned, and so I will go for the problem. The problem statement is here. A steel tank contains 6 kg of propane, liquid plus vapor at 20 degrees centigrade with a volume of 0.01 meter cube. The tank is now slowly heated. A. Will the liquid level inside eventually rise to the top or drop to the bottom of the tank? Very, very interesting. Very much in thermodynamic problem, you cannot use directly equation and solve the problem. First, you understand the concept, and after understanding the concept, you go step by step. There is no one way. You have to understand and try to go step by step, then only you can solve. So, will the liquid level inside eventually rise to the top or drop to the bottom of the tank? What if the initial mass is 1 kg instead of 6 kg? So here we have 2 issues and we will try to solve what will happen. Here answer I have given that liquid level will rise. In the second case, liquid level will fall. So this we have to see that how these things are happening. Okay, so here a very interesting issue will come in this, and I have discussed, if you see that in some of the previous classes, about the critical point. So here I will just go here. So here is the propane. In a box, the propane is inside and it is heated. So what is the question? A steel tank contains 6 kg of propane. Initially, what is the mass? Mass of propane is equal to 6 kg. State 1. Okay, 6 kg. Okay. And it is a liquid and vapor at 20 degrees centigrade. So, okay, so this mass is 6 kg. So here V, critical point. So first we have to discuss about critical point. So what is the critical point? This we have to see it here. I will draw here one PV diagram or TV diagram I will draw. So if you see here, it goes like this. And this is the critical point. So what is the critical point? It is that temperature and the specific volume. If you go above that, there will not be liquid or gas. There will be only fluid. Fluid will be there. So this is the, so means if liquid, it will be directly converted to the gas. There will not be, change of phase will not be there. So this is called the critical temperature, critical point. So in this, we have, this is the liquid line, this side, and this is the vapor line. So if you place your criteria at A, this is the A, means if your state 1 is at A, this is, I am writing A, and another is B. So in this case, in case A, if you heat in this condition, when the specific volume is less than the V critical, if the specific volume of the any substance, or here the propane is less than V critical, this A point, if you heat at A, it will go to the liquid. By heating at case A, by heating, you will go to liquid line. And if you are at B point, and if you heat at this point B, you will go here and it will be gas. So the same substance, it depends upon the specific volume. If you are in the critical zone or left side of the critical zone, and if you heat it, it will become liquid, not the gas. And if your substance is on the right side of the critical volume, then if you heat it, it will go up. So the specific volume is very much important, and it will decide whether it will become liquid or it will become the gas. So that is the problem. So now here given in this problem, it is given that VA is equal to 0.004604 meter cube per kg from steam table. From steam table. Here M is given 6 kg. So volume of the tank, is equal to 0.015 meter cube. So here specific volume V1 is equal to 0.015 divided by mass. So you will get here 0.0025 meter cube. This V1, if you see, and this is the V critical. This is the V critical. Here V critical. So we can see this V critical is less than, this V1 is a V less than V critical. Means 0.0025 is less than 0.004604. Less than V critical. So means at 6 kg you are at A, not at B. Okay, so it is at the state A, means, so at A, state A, if you heat or increase the temperature, you are going to get liquid state, not the gas. Okay, that is the first criteria. Now the second question, number B. Question number B, mass is given 1 kg. So a specific volume 0.015 divided by 1, 0.015 meter cube. So at the state B, if you see here, T and V diagram, this is your critical, this is your critical, this is A and this is the B here. So if you heat here, you will reach to gas state. So this specific volume at B is greater than specific volume of critical. So in this case, if you heat, you will reach to the gaseous zone. Gaseous zone, or you can see here at 2. But if you heat in this condition, you will reach 1, and this is the liquid. And here you will have the gas. Okay, so in this this is totally depend upon the in which area either the critical volume is more than the volume of the substance is more than the critical volume, or it is less. If it is less and you heat it, it will become the liquid. But if you are more than the critical condition, it will become the gas. So that is very important for each of us to understand the physics of these problems. You all are advised to understand how the process is behaving. Then only you should try to solve the question. That will be quite comfortable. So now I will go for the next problem. That is the problem number 1.5. So here the problem is given that a piston cylinder arrangement is loaded with a linear spring and the outside atmosphere. It contains water at 5 megapascal, 400 degrees centigrade, with a volume being 0.1 meter cube. So in one state, pressure, temperature and volume is given. If the piston is at the bottom, the spring exerts a force such that P lift is equal to 200 kilonewton. The system now cools until the pressure reaches 1200 kilopascal. Find the mass of water and specific volume V1, the final state, that is T2 and V2, and plot the PV diagram for this process. So these things we have to do it. This is our state problem, and we have to make it like this. So now I have to first I have to draw this problem. So here is this is the piston and the cylinder here. This is the piston. This is the here water is filled. This is your system dotted line. This is the H2O, and here is the one spring is loaded and it is pressing the piston. This is our diagram for this thing. Same time I will also draw the TS diagram or TV diagram, temperature and the specific volume of this issue. State 1 is given here. Given state 1, which is P1 is equal to 5 megapascal, T1 is equal to 400 degrees centigrade and V1 is equal to 0.5 meter cube. V1 is not the specific value, it is a total value of the system. So at initial condition, what is the condition is given? At initial piston volume is 0. Then the pressure is given. The pressure is, if you see here, the spring is there, force P lift. The piston is at the bottom. The spring exerts a force such that P lift is equal to 200 kilopascal. So here the P lift is equal to 200 kPa. These things are given. So this is the hypothetical condition, means the piston is at here, the volume is 0. So this, from here, this V is 0 here, and that time pressure is 200 kilopascal. This point is given. So if you make a line, this actually gives your direction of the slope. Point 1 is given. This is the point, next point 2, and this is 2 dot prime is hypothetical point. This point gives this point, I will write here 2 prime. This point gives the direction of the process. Okay, so this is not the final. 2 prime is not the final state, that is 2. It is not the final state of the 2. So we can see here that this is the problem. So now actual state is what? State 2 is equal to 1200 kilopascal, that is the P2. So now using the equation of straight line, because here the spring is given, this spring shows that our line will be straight. So by the straight line equation we can find out the exactly point 2. So here P2 minus P1 is equal to P0 minus P1 is equal to V2 minus V1 divided by V0 minus V1. So this V0 is equal to 0. It is given. Okay, so total volume V2 by V1 is equal to specific volume V2 by V1. So here this V1 can be found from superheated table. Okay, so in this way we can get the T2 is equal to 188 degrees centigrade. V2 we can get 0.01204 meter cube per kg. So in this way we can solve the problem for any such situation. Here we can see that V1 and the V2, this all the parameters we can find out from steam table, and here it is 600 degrees centigrade. So your problem will go from here to here. This is the TV diagram, and like that we can draw the PV diagram also accordingly. So these are the answers, and these are my references. So I have taken in from this problem and from also IIT Kanpur, NPTEL. These lectures are also there. I am grateful to professors, those who are making such type of lectures. Any questions, you are welcome to ask. My email is yddw. So my email is yddwivdi@gmail.com. You are welcome to ask the questions, and I will be trying to reply. In my next class, I am going to take some problem related to steam table. Okay, how to use the steam table, because this I have not covered, and I will try to solve some problems in the next class using steam table. It is very important to attend that lecture, because that will give very basic concept, so that the next time it will be very clear how to use the steam table for superheated steam, for the liquid, for the saturated steam and all. So this way it will be very interesting. So thank you very much for the joining my lecture. I wish you it will be very useful. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.